A typical problem when it comes to solving buffer problems is when you're being asked to calculate the percentage of dissociation. Notice that we have, in our previous video, we have answered a very similar problem that tells us what relationship there is between the acid and its conjugate base. If we apply the Henderson-Hasselbalch equation for this case, notice that this is the acetic acid, this is acetate over the acid, okay, and this doesn't look like a bracket there. No, the pH is 6, the pKa is 4.5, and my log of base over acid, we could calculate this again, we can just do it. So 6 minus 4.5 is log of base over acid, okay, and 1.5, or let's just do directly 10 to the power 1.5 is base over acid. That is the relationship that you should expect. Does it make sense that there is more base than acid? Well, yes, we are a pH 6 that's above 4.5, therefore it makes sense that this number here is higher than 1. That is, there is more base than acid. Okay, so expect, at least if you forget where you put the base, either in numerator and denominator, remember that increase of the concentration of base will increase your pH, and that's only true if the base is in the numerator. Now, sometimes the percentage of acetic acid means the actual percentage of the total amount of acid and base. So depending on the context, and in your homework you will be asked about that, the percentage of dissociation is the total amount, so it's the total amount of acid, that is both in acid and base form, and in the numerator there is the base. That is, the larger the amount of base you have, the more dissociated your acid is. Alright? Now, can we calculate this value here from this value that we just calculated up here? Yes, we can, just a little bit, doing a little bit of manipulation. First of all, instead of B over A, I'm going to do an A over B. So A over B is the inverse of this, so it's 10 to now negative 1.5. Okay, now let's see if I can come up with an expression such as this one. I'm going to add 1, so 1 over 1 and 1 here, so I'm just going to put B, so that is B over B, which is still 1, A over B is 10 to the 1.5 plus 1. Okay, alright, and now let's add B plus A, it's B, this is 10 to the negative 1.5 plus 1. Alright, and now if we just flip this one again, B over B plus A, and you flip this again, 1 plus 10 to the minus 1.5, there you go. You calculated, at least in fraction of 1, not percentage, but in fraction of 1, the dissociation of the acetic acid. The demonstration may be a little bit too mathematical, if you will. This number already kind of tells you the same as this number over here, but sometimes depending on the units that they ask you, you have to pay attention to that.